All right, we are in Chapter 9 of our Industrial Materials class here. We are now starting to get to the um, areas where we as machinists, machine operators, welders, fabricators, and tradespeople are a little bit more in tune with the actual material that we are getting supplied at this stage. So, Chapter 9 is about the processing of the steel to what's referred to as a finished product, or how we will actually get and use a lot of this after material after it comes to us from the steel mills themselves. So, as you take a look at again, these are the learning objectives. You can go ahead and stop the video and read through those, or you can also see them in the chapter text for these different learning objectives on Chapter 9. I'm going to come back here again. I like this chart that kind of shows really where we're at and what we're doing in terms of chapter 7, 8, and 9. Chapter 7, of course, being all how we actually get the iron ore from the ground and start to process it. We've just finished up chapter 8, where we use different cast shapes. Now, let me back up just a second. In chapter 7, of course, the ability to get semi-finished goods such as plate, sheet, strip, and bar stock. Chapter 8 was other forms that we can get material in terms of our castings, forgings, extruded materials, powder metrology type of materials. And then, of course, there was a discussion there about additive manufacturing, both in the metals side as well as in plastics. And then, of course, now we're into chapter 9. So, and we're going to be talking about how we can take any of these more complex shapes or the semi-finished goods to continue to refine and process those down into the usable parts that we need for our complicated assemblies that we work on every day. So in chapter 9 here, we're going to be going over cold rolling, cold forming. We'll talk about cutting and grinding, different joining methods. We'll talk about fabrication, all of the actual processes that we do here, whether we're in the welding shop or in the fabrication shop on the machine side, and the machining that goes on with this. Now, so that's kind of where we're at now with chapter 9. So let's take a look. Cold working steel. So everything up to this process has been what we refer to as hot working that steel. So where we are in higher temperatures, usually temperatures up above 18 or 1900 degrees Fahrenheit. Now we're going to talk more about what goes on and how we cold work this steel as well. So we roll and would continue to roll sheet. Now, notice that as far as the hot roll sheet, we don't hot roll anything under 3/16 of an inch. So as we start to get thinner and thinner with that, we'd get too much rough oxide scale on there. So anything below 3/16 of an inch gets rolled cold. So, and that is done at room temperature. So again, it's pretty similar to the hot rolling where it's done through rollers, very, very heavy rollers that are basically pinching and squeezing the material to get it to thinner and thinner sizes. So before we do that, that steel does need to be etched in acid. That helps to remove the scale. So what they call pickling. Usually this is a hydrochloric acid or a sulfuric acid that it's kind of taken in there, and the coil is fed through these acid tanks where it's washed, it comes out, it's washed, it's dried, and then it's recoiled for the cold rolling process. That iron oxide scale is returned for smelting. So now the cold rolling is typically done in 4 high rolling mills. So the operators that are doing this need to adjust that process to achieve the exact desired reduction. So of course, as we start to reduce that, one of these rollers, as you go through, as you start to thin out the material, rolling speed also becomes very, very important. So, and the tension that's on those rollers has to be controlled as well, as each one of those that material goes through each of those roll reduction rollers in a single pass. So we control the thickness through a gauge measurement. Oftentimes, this is no contact gauge measurement done with x-rays. And of course, it's usually checked at the front end, what's referred to as the nose, or the end of the coil, what's referred to as the tail, to make sure that it stays within the specified thickness. So anything that is kind of off of that, so we typically will cut off and recycle. That's of course part of our mill scrap there as well. So when we are going down into these thinner and thinner sheet goods, or even plate or strip, so we need to have better control on the actual thickness variation. So as we use that sheet metal to be done in terms of fabrication parts where we're bending or drawing or forming that, if we get variations in that thickness, that can cause material to fail and scrap in our additional processes as we start to bend or draw or punch that material as we go. So, and of course, if it's discovered where it's not a uniform reduction across the width, then that's get trimmed off as well. So we're really trying to minimize the scrap, or I should say, the mills are really trying to minimize scrap as much as possible. In the cold rolling process itself, we do get some work hardening, which makes sense as we try to compress and add force to that material to shrink it down. On the molecular level, we are continuing to cause the bonds to slip and break, and that causes some work hardening there to happen. So our ductility in the material decreases. We can get edge cracks to be formed. Of course, those cracks need to be trimmed out as well. So, and we can't, or the mill is not going to ship any of that product to a customer as well, because that's considered a bad product. So it all has to be trimmed and make sure that it's good before it gets shipped. There is an annealing process that takes place at this time as well. So we can either anneal this individually as it's uncoiled, or in the coil altogether. Annealing is done as a much lower temperature of 1200 degrees Fahrenheit or above. So, and then of course it's air cooled from that point. So there are advantages to the annealing. So generally less complex ovens. Our ovens don't need to be able to get to as high of a temperature. So that would definitely an advantage, especially right now as we're concerned with our energy use. So if we talk about disadvantages here too, this is, of course, it usually does take a longer time to do that. So oftentimes it's 15 to 24 hours to anneal some of this material, as opposed to an hour or two. So if we're talking about higher temperature process annealing, this is done at 14 to 1600 degrees Fahrenheit. So usually that only requires an hour in the furnace, but it does require higher energy outputs. It does need to be more controlled, and you also have to have good seals on the doors to make sure that you're maintaining that temperature in order for it to work right. So here's just a kind of an example of how this coil or strip would be being fed through. You can kind of see the looping that goes on inside of these. Of course, the person at the front would be pulling and feeding all that through as it comes in, and then of course it's attached to the take-up reels that are back here in order to recoil that as well. So there's two ways that we can anneal it, either as a stationary annealing or continuous annealing. So the stationary, it's kept in the coil. So, and we basically have larger ovens where it's just all done all at once versus the strip where it's fed through. And there's some differences in the results that we get with either one of those depending on what the requirements are. So just a little bit of a breakdown here. You can go through and take a look at the chart. So get a better idea of how much of an impact stationary versus continuous annealing takes place. All of this, of course, is used to give us our material that we're used to working it at. Now, in my background with working in the canning industry with the machinery that makes your cans, the material, especially the aluminum material, would be supplied in these large rolled coils just like this, and those coils would then be put onto the canning lines and start to feed into, and that would all be coming off as well. Now for us, we are probably much more familiar with this becoming and being cut down to 8-foot sheets, or maybe strips or other size material based on what we're ordering and what we're needing. So as well, but so you will get that here, and this is the way it comes to us. We will be looking next at, as we kind of go through to the next stage, we'll kind of get more into cold roll steel. So notice as we take a look at this, so I'm going to stop. So we'll come back and we'll talk about forming and what goes on with forming in the next video that goes along with chapter 9 here.